1 Amazon Redshift. 2x faster than fastest competitor. 10x faster than Redshift 2 YRS ago. Starts 25 cents per HR. Scales up to petabytes. 75% less cost effective. With Redshift Spectrum, we can run complex queries on data stored in S3. We can use WLM in the parameter group configuration of Redshift to define number of query queues and how queries are routed to those queues. For Redshift, spot instances are not an option. We can't use auto-scaling with RDS. To improve performance, we should look to sharding instead. Starting from June 20th, 2019, we can use auto-scaling with RDS instances. To use readies auth with Elastic, in-transit encryption must be enabled for clusters. In case of a failover, Amazon RDS flips the canonical name record, name, for your DB instance to point at the standby URL, https://aws.amazon.com/about-news/2019/06/rds-storage-auto-scaling. Amazon Redshift allows you to query data in your data lake without moving it or transforming it into a set schema. YouTube URL, https://www.youtube.com/watch?b=zvaqjtz5jrs. February 14, 2013 launch. Designed to reduce I/O. Scan relevant block for query. Column grow and shrink. Amazon Redshift extends data warehouse queries to your data lake, with no loading required. 2 months free. Slice, virtual compute node. Each compute node has either 2,1632 slices. Slices processes its own data. 1.1 key features. 1.1.1 notable feature. DynamoDB supports both key value and document data models. Each row can have any number of columns at any point in time. DynamoDB Accelerator, DAX, is an in-memory cache that delivers fast read performance for your tables at scale by enabling you to use a fully managed in-memory cache. Using DAX, you can improve the read performance of your DynamoDB tables by up to 10 times. Automated global replication with global tables. DynamoDB global tables replicate your data automatically across your choice of AWS regions. With global tables, your globally distributed applications can access data locally in the selected regions to get single-digit millisecond read and write performance. DynamoDB Streams. DynamoDB Streams capture a time-ordered sequence of item-level modifications in any DynamoDB table, and store this information in a log for up to 24 hours. Applications can benefit from the ability to capture changes to items stored in a DynamoDB table at the point in time. 1.1.2 Faster performance. Massively parallel. Amazon Redshift delivers fast query performance on datasets ranging in size from gigabytes to exabytes. Redshift uses columnar storage, data compression, and zone maps to reduce the amount of I/O needed to perform queries. It uses a massively parallel processing, MPP, data warehouse architecture. Machine learning. Amazon Redshift uses machine learning to deliver high throughput, irrespective of your workloads or concurrent usage. Redshift utilizes sophisticated algorithms to predict incoming query runtimes, and assigns them to the optimal queue for the fastest processing. Result caching. Amazon Redshift uses result caching to deliver sub-second response times for repeat queries. Dashboard, visualization, and business intelligence tools that execute repeat queries experience a significant performance boost. When a query executes, Redshift searches the cache to see if there is a cached result from a prior run. 1.1.3 Easy to set up, deploy, and manage. Automated provisioning. Amazon Redshift is simple to set up and operate. Automated backups. Amazon Redshift automatically and continuously backs up your data to Amazon S3. Redshift can asynchronously replicate your snapshots to S3 in another region for disaster recovery. Fault tolerant. Redshift continuously monitors the health of the cluster, and automatically re-replicates data from failed drives and replaces nodes as necessary for fault tolerance. Flexible querying. Flexibility to execute queries within the console or connect SQL client tools, libraries, or other tool. Integrated with third-party tools. 1.1.4 Cost-effective. No upfront costs, pay as you go. You can start small for just 25 cents per hour with no commitments. Predictable cost. Even with unpredictable workloads, Amazon Redshift allows customers to scale with minimal cost impact, as each cluster earns up to 1 hour of free concurrency scaling credits per day. Choose your node type. 1.1.5 Scale quickly to meet your needs. Petabyte scale data warehousing. Exabyte scale data lake analytics enables you to run queries against exabytes of data in Amazon S3 without having to load or transform any data. Limitless concurrency. Amazon Redshift provides consistently fast performance, even with thousands of concurrent queries, whether they query data in your Amazon Redshift data warehouse, or directly in your Amazon S3 data lake. Redshift Spectrum executes queries across thousands of parallelized nodes to deliver fast results, regardless of the complexity of the query or the amount of data. 1.1.6 Query your data lake. Amazon S3 Data Lake. Amazon Redshift is the only data warehouse that extends your queries to your Amazon S3 data lake without loading data. You can query open file formats you already use, such as Avro, CSV, Grok, JSON, Orc, Parquet, and more, directly in S3. AWS Analytics Ecosystem. Amazon Redshift is natively integrated with the AWS Analytics ecosystem. AWS Glue can extract, transform, and load ETL data into Redshift. Amazon Kinesis Data Firehose is the easiest way to capture, transform, and load streaming data into Redshift for near real-time analytics. You can use Amazon QuickSight to create reports, visualizations, and dashboards. 1.1.7 Secure. End-to-end encryption, SSL in transit, AES 256 at rest. Network isolation, firewall, VPC, VPN. Audit and compliance, integrates with AWS CloudTrail. Amazon Redshift is compliant with SOC 1, SOC 2, SOC 3, and PCI DSS Level 1 requirements. 1.2 Clusters and nodes. The key component of an Amazon Redshift data warehouse is a cluster. A cluster is composed of a leader node and one or more compute nodes. Amazon Redshift currently has support for 6 different node types. The 6 node types are grouped into 2 categories: dense compute and dense storage. The dense compute node types support clusters up to 326 TB using fast SSDs. Dense storage nodes support clusters up to 2 PB using large magnetic disks. Each cluster contains one or more databases. The number of slices per node, 2 to 16. Add performance by adding node. When you submit a query, Amazon Redshift distributes and executes the query in parallel across all of a cluster's compute nodes. Amazon Redshift also spreads your table data across all compute nodes in a cluster based on a distribution strategy that you specify. This partitioning of data across multiple compute resources allows you to achieve high levels of performance. Whenever you perform a resize operation, Amazon Redshift will create a new cluster and migrate data from the old cluster to the new one. Figure 1 Redshift Architecture. Client applications. Amazon Redshift integrates with various data loading and ETL, extract, transform, and load tools and business intelligence, BI, reporting, data mining, and analytics tools. JDBC connection in SQL Workbench/J. Connect to your cluster programmatically. Connect to your cluster by using the PSQL tool. Connections. Amazon Redshift communicates with client applications by using industry standard JDBC and ODBC drivers for PostgreSQL. Clusters. The core infrastructure component of an Amazon Redshift data warehouse is a cluster. A cluster is composed of one or more compute nodes. If a cluster is provisioned with 2 or more compute nodes, an additional leader node coordinates the compute nodes and handles external communication. Leader node. The leader node manages communications with client programs and all communication with compute nodes. It parses and develops execution plans to carry out database operations, in particular, the series of steps necessary to obtain results for complex queries. Based on the execution plan, the leader node compiles code, distributes the compiled code to the compute nodes, and assigns a portion of the data to each compute node. The leader node distributes SQL statements to the compute nodes only when a query references tables that are stored on the compute nodes. Compute nodes. The leader node compiles code for individual elements of the execution plan and assigns the code to individual compute nodes. The compute nodes execute the compiled code and send intermediate results back to the leader node for final aggregation. Each compute node has its own dedicated CPU, memory, and attached disk storage, which are determined by the node type. Amazon Redshift provides 2 node types, dense storage nodes and dense compute nodes. Each node provides 2 storage choices. You can start with a single 160 GB node and scale up to multiple 16 TB nodes to support a petabyte of data or more. Node slices. A compute node is partitioned into slices. Each slice is allocated a portion of the node's memory and disk space, where it processes a portion of the workload assigned to the node. Internal network. Amazon Redshift takes advantage of high bandwidth connections, close proximity, and custom communication protocols to provide private, very high-speed network communication between the leader node and compute nodes. The compute nodes run on a separate, isolated network that client applications never access directly. Databases. A cluster contains one or more databases. User data is stored on the compute nodes. Your SQL client communicates with the leader node, which in turn coordinates query execution with the compute nodes. Columnar storage. Columnar storage for database tables is an important factor in optimizing analytic query performance. It drastically reduces the overall disk I/O requirements and reduces the amount of data you need to load from disk. Using columnar storage, each data block stores values of a single column for multiple rows. Internal architecture. Warning, empty page. 1.3 Table design. Each Amazon Redshift cluster can support one or more databases, and each database can contain many tables. In addition to columns and data types, the Amazon Redshift create table command also supports specifying compression encodings, distribution strategy, and sort keys. 1.4 Data types. Amazon Redshift columns support a wide range of data types. All types. Additional columns can be added to a table using the alter table command, however, existing columns cannot be modified. 1.5 Compression encoding. One of the key performance optimizations used by Amazon Redshift is data compression. When loading data for the first time into an empty table, Amazon Redshift will automatically sample your data and select the best compression scheme for each column. 1.6 Distribution strategy. The data distribution style that you select for your database has a big impact on query performance, storage requirements, data loading, and maintenance. By choosing the best distribution strategy for each table, you can balance your data distribution and significantly improve overall system performance. When creating a table, you can choose between one of three distribution styles: even, key, or all. Even distribution. This is the default option and results in the data being distributed across the slices in a uniform fashion regardless of the data. Key distribution. With key distribution, the rows are distributed according to the values in one column. The leader node will store matching values close together and increase query performance for joins. All distribution. With all, a full copy of the entire table is distributed to every node. This is useful for lookup tables and other large tables that are not updated frequently. 1.7 Sort keys. Sorting enables efficient handling of range-restricted predicates. If a query uses a range-restricted predicate, the query processor can rapidly skip over large numbers of blocks during table scans. The sort keys for a table can be either compound or interleaved. A compound sort key is more efficient when query predicates use a prefix, which is a subset of the sort key columns in order. An interleaved sort key gives equal weight to each column in the sort key, so query predicates can use any subset of the columns that make up the sort key, in any order. 1.8 Redshift FAQ. 1.8.1 General. Amazon Redshift is a fast, fully managed data warehouse that makes it simple and cost-effective to analyze all your data using standard SQL. It allows you to run complex analytic queries against petabytes of structured data, using sophisticated query optimization, columnar storage on high-performance local disks, and massively parallel query execution. With Redshift, you can start small for just 25 cents per hour with no commitments and scale out to petabytes of data for $1,000 per terabyte per year, less than a tenth the cost of traditional solutions. Amazon Redshift also includes Amazon Redshift Spectrum, allowing you to directly run SQL queries against exabytes of unstructured data in Amazon S3. No loading or transformation is required, and you can use open data formats, including Avro, CSV, Grok, Ion, JSON, ORG, Parquet, RC file, regexcerta, sequence file, text file, and TSV. Redshift Spectrum automatically scales query compute capacity based on the data being retrieved, so queries against Amazon S3 run fast, regardless of data set size. Amazon Redshift supports VPC, SSL, AES-256 encryption, and HSMs. What is Redshift Spectrum? Is a feature of Amazon Redshift that enables you to run queries against exabytes of unstructured data in Amazon S3, with no loading or ETL required. Redshift Spectrum scales out to thousands of instances if needed, so queries run quickly regardless of data size. Redshift Spectrum lets you separate storage and compute. What does Amazon Redshift manage on my behalf? Set up, operate, and scale a data warehouse. Provisioning the infrastructure capacity to automating ongoing administrative tasks, backups, and patching. Amazon Redshift automatically monitors your nodes and drives to help you recover from failures. For Redshift Spectrum, Amazon Redshift manages all the computing infrastructure, load balancing, planning, scheduling and execution of your queries on data stored in Amazon S3. Performance of Amazon Redshift compared to most traditional databases. Columnar data storage. Advanced compression. In addition, Amazon Redshift doesn't require indexes or materialized views. When loading data into an empty table, Amazon Redshift automatically samples your data and selects the most appropriate compression scheme. Massively parallel processing, MPP. Amazon Redshift automatically distributes data and query load across all nodes. Amazon Redshift makes it easy to add nodes to your data warehouse and enables you to maintain fast query performance as your data warehouse grows. Redshift Spectrum. You can create a cluster using either dense storage, DS, node types or dense compute, DC, node types. Dense storage, DS, XL2 TB and 8XL24 TB. Dense computer, the large has 160 GB of SSD storage, 2 Intel Xeon E5-267V2, Ivy Bridge, virtual cores and 15 GB of RAM. Amazon Redshift's MPP architecture means you can increase your performance by increasing the number of nodes in your data warehouse cluster. An Amazon Redshift data warehouse cluster can contain from 1 to 128 compute nodes, depending on the node type. 1.8.2 New General. 1.9 Redshift Lab. Figure 2 Redshift Intro Screen. Figure 3 Creating Redshift Cluster. Warning, empty page. Figure 4 AWS Snapshot. Figure 5 Manual Snapshot. Figure 6 Tools to find compute requirement. 1.9.1 Matrix monitored in Redshift. 1 Queries. 2% disk space used. 3 Space reclaimed by auto vacuum delete, in MB. 4 CPU utilization. 5 Network receive throughput. 6 Network transmit throughput. 7 Write IOPS. 8 Write throughput. 9 Write latency. 10 Read IOPS. 11 Read throughput. 12 Read latency. 13 Database connections.